Since I'm not going to be here today, I'm in Arizona meeting my new grandbaby. I thought I would just do you a little introduction to current electricity. We've been studying static electricity, which is just electricity in one place. And current electricity is the flowing electricity, like we see flowing through the wires in the walls and lighting our light bulbs and running our machinery and so forth. And that's what we're going to be studying now. When you see the word current, what do you think of? Just think of a stream flowing or wind flowing. It's a current. It's something flowing. And that's what current electricity is. Current electricity is flowing electricity. Current electricity flows in what? It flows through a wire. It's got to start someplace, go around, come back to where it started. What do we call that? What's the word you think of when you think of electricity flowing through a pathway? Anybody got it? It's the word circuit. I'm sure some of you were thinking of that. A circuit just means to go around a path, to end where you started and maybe go around again. For electricity to flow in a current, it's got to have a complete circuit. So let's take a look at an example of a circuit. Let's look at an example of a different kind of circuit before we talk about electricity, though. Let's talk about a water circuit. Imagine that this is a water pump, pumping water, and let's draw a pipe for the water to go through. And you notice there's a little kink down there in the pipe, a smaller pipe. And then we'll draw a valve. Valve can have a handle on it to turn the valve on and off. And then we'll complete the circuit of water. So here we have a pump pumping water, a current of water through the pipe. So the pump puts a force on the water. It makes the water flow. Now, if the current is flowing in one part of the pipe, wouldn't you think it has to have the same current flowing in every other part of that pipe? It sure does, because there's only one path. If it's moving in one place, it's got to be moving in the other place. Well, what about that little kink down there? That'll make it flow less, but not just in that one spot. It makes it flow less everywhere. If there's a kink in the pipe one place, just think of kinking a hose. If you're spraying on something and you kink the hose, all the water flows slower in the hose, not just that one spot. So I put a kink in there and the current flows slower everywhere. Now I want you to think about this. Does the pump actually make water? Well, of course not. The water's already in the pipes, and the pump is just putting a force on the water to push the water through the pipes. It's not making water at all. It's just pushing the water through the pipes. We can turn the valve on and off. We turn the valve off, the water will stop flowing. So that's kind of a picture of a water current. Now let's talk about an electrical current. You see that first at the top there, those short and long lines, that's a picture of a battery. That's how we draw a battery in an electrical circuit. It's got a positive side and negative side. And the long and short lines tell us how many cells we are. We could put more cells to make a more powerful battery. But the battery's hooked to a wire, and that wire goes down and is hooked to a light bulb. That's a picture of a light bulb. And let's go on in our circuit. There's a picture of a switch. That's how we would draw a switch in an electrical circuit. And we'll complete the circuit back to the battery. Now, can electricity flow now? Well, no, because the switch is not closed. The switch is open. It's like having the valve closed on the water. No water can flow. And when that switch is open, no electricity can flow. So let's close the switch, and now electricity can flow. And so just like water flows in a current through the pipes, electricity flows as a current through the wire. And just like in the pipes, if electricity is flowing in one place, it has to be flowing the same in the other place because we only have one pathway for it to go. So if there's current in one place, we have the exact same current in another place. Now you notice the light bulb down there. The light bulb acts just like that kink in the water pipe. It resists the flow of electricity. It takes some push to get that electricity through the light bulb. We'll call that light bulb a resistor because it resists the flow of electricity. Now you might think that the battery makes electricity, but that's not true. Just like the water pump pumps water through the pipe, the water is already in the pipe. Aren't there already electrons in the wires? If it's copper wire, copper has electrons in the atoms, so the electrons are already in the wire. And remember, electricity is just electrons moving around. So the electrons are already in the wire, just like water's already in the pipes. And so when we close the switch, all the battery does is provide a force, which we call voltage. Voltage is just the force that pushes the electrons around the wire. The electrons are already in the wire, just like the water is already in the pipes. The pump just pushes the water around the pipes. The battery just pushes the electrons around the wire. We actually talk about batteries improperly sometimes. We'll talk about a rechargeable battery. We're going to recharge the battery. Batteries really do not have charge. The charge is already in the wires. That's the electrons in the wires. The battery just pushes the charge around. It just creates a force, the voltage, to push the charge around and create current. Current is just the electrons flowing through the circuit. Now, we could put a bulb in there that has more resistance. That would be like putting a smaller kink in the pipe. It would slow down the current. Less current could flow. Or we could make a bigger battery, put more voltage on the battery, more push. That would be like putting a bigger pump on our water circuit, and we could push more current through that resistor. So I want you to just think of the electricity flowing through a wire like water flowing through a pipe. And the battery doesn't make electricity. It just pushes the electrons around that are already there. Now, what would happen if we put another bulb in next to this bulb? We have two bulbs in there, two resistors. That would slow the current down even more. And the electricity is flowing one path through both bulbs. This is called a series circuit. Series, everything's in line. There's only one path. You can always tell a series circuit because there's only one path for the electricity to go through. What happens if one of those bulbs burns out? You ever had one of those cheaper Christmas tree light sets where if one bulb burns out, they all go out? There's only one wire connecting the different bulbs. That's a series circuit. So if one bulb burns out, it breaks the pathway for the electricity. It's an open circuit, and the current can't flow anymore. So that's one way you can tell a series circuit. Everything's in one path. If something breaks, then there's no way the electricity can flow anymore. That's one type of a circuit. We also have what's called a parallel circuit. And you can see here's a picture of a parallel circuit. We get the current flowing out of the battery, but now that current can go three different directions once it splits into those branches. Now what would happen if one of the bulbs burns out? Well, the others will keep burning because there's still a pathway for them to go through, for the electricity to go through, for the current to flow through. Think about your house. Is it wired in series or parallel? Well, in parallel, of course, because if one light bulb burns out, the whole house doesn't shut down. So our houses indeed are wired in parallel. Now you notice the current going back into the battery would be the same as the current leaving the battery because it adds back together again. So basically what I want you to get from this brief introduction is that electricity is not created by a battery. It's already in the wires. The electrons are already in the wires. The battery is just like a pump that pushes those electrons through the wires. We can put resistors in there that slows down the current. We could make a bigger battery that pushes the current harder and makes more current flow. If we put too big a battery in, we can burn out the light bulb because we put too much current through that. Just like if we put too big of a pump on the water circuit, we could blow up the pipes because we would put too much pressure inside the pipes. So that's an introduction to electricity, electrical circuits. And again, the basic thing I want you to get is batteries don't create electricity. They just push the electrons through the wires that already are there, like a pump pumps water through water pipes. And we have two types of circuits. We have a series circuit and a parallel circuit. We'll explain that more next time. Just wanted to do an introduction for you guys. Hope you're having a great day and did well on the test.